Welcome to the Explainer. Look, we all know artificial intelligence has totally taken over the headlines, our workplaces, and our homes. But today, we're moving past the buzzwords and looking directly at the concrete mechanics powering the tools you already use every single day.
Take a second and really think about your daily tech habits. Do you recognize any of these everyday tools? Just consider your morning routine, your commute, or how you operate at work. I mean, from that iconic ChatGPT interface and autonomous Teslas, right down to delivery robots and the Alexa sitting in your living room, these aren't just random diverse products. They're all everyday examples of artificial intelligence in action, and they are powered by the exact same core architecture. So, we're going to break this whole thing down into 4 quick chapters. 1. What is artificial intelligence? 2. Narrow versus agentic AI. 3. How AI models learn. And 4. The Turing test. All right, Chapter 1. What is artificial intelligence? Let's define the actual technology behind all the buzzwords. When you strip away the sci-fi magic, artificial intelligence ultimately boils down to this: machines performing tasks to imitate human intelligence through sheer mathematical calculation and really complex algorithms. It is fundamentally just a mathematical system designed to replicate how we think. And what's wild is that this exact same mathematical architecture scales across vastly different applications. It's what allows complex operations like autonomous driving and chatbots to function, sure. But it's literally the exact same foundational math that curates your social media feed or, predicts your next Netflix binge. From driving a car to picking a movie, the underlying mathematical principles are completely identical. Moving right along to Chapter 2, Narrow versus Agentic AI, let's look at the spectrum of machine intelligence. So on one end of the spectrum, we have what's called narrow AI. And despite the fancy name, these actually aren't considered truly intelligent. They are highly specific, constrained, task-based tools. Think about the YouTube recommendation algorithm, Siri, facial recognition, or Grammarly. They execute one very specific function based on their programming. But as we move down the spectrum, we hit agentic AI. Now, this is where systems operate with serious autonomy and deep complexity. We're talking advanced cancer screening, DALL-E-generating art, Tesla's auto-driving cars, and highly responsive models like ChatGPT. Which brings us to Chapter 3, How AI Models Learn. Time to finally peel back the curtain on the training process. Building these models, especially the large language ones, relies on 4 very distinct sequential building blocks: scraping, modeling, heuristics, and feedback loops. Every single intelligent model has to go through this exact journey. Let's break them down. It all starts with Stage 1, scraping. Think of this as gathering the raw materials. Mountains of data, I'm talking online posts, videos, uploaded images, are literally just scraped right off the internet. This unimaginably large database of scraped content is exactly what trains the AI to eventually understand how humans communicate. Once they've hoarded all that data, we move to Stage 2, modeling. Now, the AI doesn't just read this data, it maps it mathematically. It observes the probabilistic patterns of human language, so it learns that if the input is hello, the statistically correct output is to say hello back. It is literally modeling human behavior based on the millions of times it recognized that pattern in the scraped data. Then comes a really vital human element in Stage 3, heuristics. This is where prompt engineers step in to help train the AI using a specific scoring system. They test the pattern recognition by feeding it random sentences. If the AI gives a good answer, it's awarded. If it responds poorly, it's told to try again. Crucially, this is also the stage where the AI is given its boundaries, learning definitively that it shouldn't execute actions like breaking the law or encouraging harm. Finally, we reach Stage 4, feedback loops. The AI is released to the public, and humans begin to use it in the real world. But the learning absolutely does not stop there. The AI continuously evaluates user interactions, analyzes external posts about its performance, and checks user ratings. It takes all of this messy, real-world interaction and feeds it right back into its own system to become even more accurate and capable over time. And that brings us to Chapter 4, the Turing test, the ultimate benchmark for artificial intelligence. So after all this extensive training, how do we actually measure if a machine has achieved true intelligence? Well, that's where the Turing test serves as our philosophical benchmark. Basically, a human evaluator asks a series of questions to both a human and a robot. The evaluator then carefully compares those answers and tries to guess which one came from the machine. If the answers sound so genuinely human that the evaluator can't tell the difference, boom, the AI has passed. Check this out. A human evaluator asks, "What is the purpose of dying?" the machine's calculated response? To have a life. That is an actual, deeply philosophical answer provided by a machine during testing. It perfectly demonstrates how a system of mathematical algorithms, once trained on enough data, can produce a response so profound that it totally blurs the line between human empathy and probabilistic calculation.
To wrap up our explainer today, I want to leave you with one final provocative thought. Imagine you are sitting in the evaluator's chair for the Turing test. If you were given the chance right now, what specific question would you ask that you think would immediately tell you if you were speaking to an AI or a human? What is that uniquely human spark that math simply cannot imitate? Think about it and see if you could outsmart the machine. Thanks for joining me on The Explainer.